Hey everyone, on today's PortSwigger SSRF Lab, we're going to be looking at how applications attempt to defend against server-side request forgery attacks and how attackers can sometimes bypass those protections using alternate IP representations, redirects, and URL parsing inconsistencies, even if they have controls in place to prevent attackers from getting into application servers. We're going to figure out how you can do this. So instead of just solving the lab this time, we're going to be focusing on the attacker methodology, backend trust relationships, and mitigation strategies. Let's go.
All right, well, let's go ahead and get started. So we're looking at the SSRF with Blacklist-based input filter lab with PortSwigger. This is lab number 3 for SSRF. And again, just a recap of what SSRF is. It's a server-side request forgery, which is a vulnerability you can find on web applications where an attacker tricks a server into making a request on their behalf. So as an attacker, what I'm doing is abusing this trusted server functionality uh, to access internal or protected resources that I should not, as an attacker, have access to. So think of it like this. Say you go into a building where you're not allowed to go past the security guards. You don't have a badge, you can't get in. But there's a security guard that the company trusts this. And so you ask the security guard, hey, I need you to access a few doors that are locked. I need you to go get some information that I need. Can you go get it? And so the security guard says, yeah, I can go get that information. So he has a badge, right? So he's going to go in, he can unlock doors, he can access restricted areas and come back and give you the information you need. So this is exactly what we're doing with server-side request forgery. We are telling an internal server, which is the website, to go get information for us. And so we're manipulating the application to gain internal access to an admin site. And so, yeah, this is what we're doing essentially. And let's take a look um, at this lab. Again, I mentioned earlier that we're going to do it with an attacker mentality. So we want this methodology, which is the why behind all this. Um, why does it happen? Why are we doing this? Why is it important? What's the impact to the company? What's the risk? We're going to look at all of these things. And these are things that are important for you to keep in mind when you're working on these labs, because you don't want to just go through the labs. You want to really understand how they work, why they work the way they do. How do you manipulate them? What access can you get from all this? Like, what's the benefit for you as an attacker? But then also, we want to look at the good side, right? We want to be blue. So, what are some of the things that will strengthen the security of a company by us implementing certain protocols? Like, what protocols can we establish, or what protections or validation methods we can establish to better secure the environment? Right away, the lab is telling us what we're going to look for, which is the stock check. All right. And to solve this, we need to change the stock check URL to access the main interface at the admin location. And we're going to delete Carlos. Now, what are some validations that have been established, or some of the things that we have to think about? I know before when we started the video, I mentioned that we're going to do this with the attacker mindset methodology of why are we doing this, right? So we want to keep these we want to have these questions and keep them in mind. Validation. What is there already? Well, the developer has deployed two weak anti-SSRF defenses that we, as an attacker, need to bypass. So in our case, we're looking at, sorry, I'm going to go ahead and access lab. So we're looking at the parameter that controls the request. That's what we're looking for as an attacker. In this case, we know it's the stock is what fetches data from the internal system. So we want to know at this point, what is that parameter that is going to control that request? So we're going to go ahead and select any of these is fine. and I'm going to click on check stock. And let's take a look at burp suite here. So it's catching history, and we have a lot of information that there's so much noise. So let's make it easy for us. I'm going to go ahead and clear history here, and let's start fresh, okay? So I'm not going to open browser again because we already have a browser open. So I'm going to go back to Chromium, and now I'm going to click on check stock this time and pull up burp suite. And as you can see, burp suite gave me a statuses that are important for us and that are going to be useful. So status code 200, the status code 200 means that it's okay. The request was successfully received, processed, and returned by the server. So this is good. This is what we're looking for. And then you have that stock um, location that is a good pointer where you can immediately say, oh, this is where I want to go to get what I need. And it is. As you can see, it has the stock API, which is the parameter we're looking for. So I'm going to go ahead and right click on this. And then I'm going to go select send to repeater, which is going to send it right here. And now we can manipulate this information here, put whatever we want, and then we can send it to response, right? Before we do that though, I'm going to make this pretty or something that is better or easier to read. So I'm going to do Control Shift U, and it's going to make it look a little bit more decent. And this is what we want. So again, let's go back to that lab information. And so it's saying to change the stock check URL to this here. So let's go ahead and do that. I'm just going to go ahead and copy and paste this over here, and let's see what happens. I'm going to send it and get a response. What is the response? External stock check blocked for security reasons. So there's the developer. This is what they set up as validation, right? So what is a validation? Validation is pretty much checking whether user input is acceptable before processing it. And well, they're saying no, you can't do that and come in. Like we can't process this information for you. So we're gonna say stop right there. Let me get rid of admin. Maybe that we're not there yet, and localhost is gonna work. And no, it's not. What about 127.00.0.1? It worked before in other labs, right? You remember? But in this case, it is not. Added another zero there, and I shouldn't have, so I removed that zero, and we're still getting the um, bad request 400. And so at this point, we have to start thinking of bypass alternatives. If I type in the IP address in a different way, is it going to work? And so let's go ahead and delete a few things, and let's see if this works. And we're getting somewhere. Let's take a look at render and see what exactly we're looking at. Okay, so we're inside the page, and then different from what we had before, there is admin panel available there. Let's go back to Chromium and let's see what we have. Okay, so if we go back, the admin panel is not there, but guess what? It is in our lab environment. See? So we're getting somewhere is what I'm saying. And so we need to keep going. We're on the right track until we get to the admin location. So what if we just type in admin? Will that work? Let's go ahead and send it over. And nope, developers knew about this and they blocked us. All right, so what else can we try? How about if we try encoding, which is transforming characters into another representation by changing this and encoding it. So I'm just going to highlight the A. We're going to right click and we're going to go to convert selection URL and encode all characters. And there you go. Let's test this out. Let's see if it works. And it's not. Why don't we try it again? We're going to go ahead and right click it or select it, then right click. And then we're going to go to convert selection and we're going to do all characters again. Let's see what happens. Let's give it a shot. And look at that. We're in. Oh, all right. Okay, so you have the options here to delete Carlos, but you can't do anything about it. However, we're going to go back to raw and we're going to see that we are able to delete a couple of users. All right. So this is exactly where we want to be. Now, I'm going to go ahead and um, select this and just paste it here. Well, we want to bring the forward slash, and then we're going to copy this, and then we're going to run it again so we can delete Carlos. And so after doing that, we have a 302 found, which is technically, it means that the action pretty much likely succeeded. So it means something happened and now you got redirected afterwards. So something occurred. So what we're gonna do now is test it and see what changed, what occurred. Let's go to render, see what happens. But before we do that, I'm gonna go back here, delete what we had, and I'm gonna send this, and then we're gonna go to render. Hey, look, congratulations, you solved the lab, so Carlos is no longer there. If you go to raw, you're not gonna be able to find him or Carlos, and yeah, so there's only one person, and Carlos is gone. So perfect. So we completed the lab. Now we have to think about what are some of those mitigation strategies that will help a company defend themselves against something like this. So some of the things that you have to look out for could be implementing strict allow list based URL validations, blocking requests to internal private IP ranges, validating final redirect destinations, and restricting unnecessary outbound server communication through network segmentation and egress filtering. So these are things that can definitely help a company better protect against these types of attacks. All right, that completes our lab. Again, this is David with Practical Cyber Lab. Thank you for watching, and I will be seeing you in the next lab walkthrough. Bye bye.